Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Machine Learning Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You work for a hospital. You received approval to collect the necessary patient data, and you trained a Vertex AI tabular AutoML model that calculates patients' risk score for hospital admission. You deployed the model. However, you're concerned that patient demographics might change over time and alter the feature interactions and impact prediction accuracy. You want to be alerted if feature interactions change, and you want to understand the importance of the features for the predictions. You want your alerting approach to minimize cost. What should you do? The options are: Option A, create a feature drift monitoring job. Set the sampling rate to 1 and the monitoring frequency to weekly. Option B, create a feature drift monitoring job. Set the sampling rate to 0.1 and the monitoring frequency to weekly. Option C, create a feature attribution drift monitoring job. Set the sampling rate to 1 and the monitoring frequency to weekly. Option D, create a feature attribution drift monitoring job. Set the sampling rate to 0.1 and the monitoring frequency to weekly.
To arrive at the correct answer, we focus on the keywords: alerted if feature interactions change, understand the importance of the features, minimize cost.
The correct answer is option D, create a feature attribution drift monitoring job. Set the sampling rate to 0.1 and the monitoring frequency to weekly.
Why is this correct? D. Feature attribution drift monitoring detects changes in feature interactions and provides feature importance for predictions. Setting a lower sampling rate, 0.1 instead of 1, processes fewer requests, effectively minimizing the monitoring cost. Why are the others incorrect? A. Feature drift monitoring only tracks changes in the distribution of individual features, not interactions or feature importance. A sampling rate of 1 does not minimize cost. B. Feature drift monitoring tracks the statistical distribution of individual features, which fails to capture changes in feature interactions or provide feature importance. C. While feature attribution drift monitoring addresses the requirements for interactions and importance, a sampling rate of 1 processes every request, which does not minimize cost.
You have created a Vertex AI pipeline that includes 2 steps. The first step pre-processes 10 terabytes data completes in about 1 hour, and saves the result in a cloud storage bucket. The second step uses the process data to train a model. You need to update the model's code to allow you to test different algorithms. You want to reduce pipeline execution time and cost while also minimizing pipeline changes. What should you do? The options are: Option A, add a pipeline parameter and an additional pipeline step. Depending on the parameter value, the pipeline step conducts or skips data pre-processing and starts model training. Option B, create another pipeline without the pre-processing step and hardcode the pre-processed cloud storage file location for model training. Option C, configure a machine with more CPU and RAM from the compute-optimized machine family for the data pre-processing step. Option D, enable caching for the pipeline job and disable caching for the model training step.
To arrive at the correct answer, we focus on the keywords: first step pre-processes, second step uses the process data to train a model, update the model's code, reduce pipeline execution time and cost, minimizing pipeline changes.
Correct answer is option D, enable caching for the pipeline job and disable caching for the model training step.
Why is this correct? D. Vertex AI pipeline supports execution caching. Enabling it caches the expensive 1-hour pre-processing step's output. Disabling caching only for the modified training step ensures it runs with the new code, effectively reducing time and cost with minimal changes. Why are the others incorrect? A. Introducing new parameters and conditional steps adds unnecessary complexity and manual management, which violates the requirement to minimize pipeline changes. B. Creating an entirely separate pipeline requires significant overhead, code duplication, and maintenance, directly contradicting the requirement to minimize pipeline changes. C. Upgrading compute resources increases costs and still redundantly executes the pre-processing step, failing the objective to reduce overall pipeline execution time and cost.
You work at a subscription-based company. You have trained an ensemble of trees and neural networks to predict customer churn, which is the likelihood that customers will not renew their yearly subscription. The average prediction is a 15% churn rate, but for a particular customer the model predicts that they are 70% likely to churn. The customer has a product usage history of 30%, is located in New York City, and became a customer in 1997. You need to explain the difference between the actual prediction, a 70% churn rate, and the average prediction. You want to use Vertex Explainable AI. What should you do? The options are: Option A, train local surrogate models to explain individual predictions. Option B, configure sampled Shapley explanations on Vertex Explainable AI. Option C, configure integrated gradients explanations on Vertex Explainable AI. Option D, measure the effect of each feature as the weight of the feature multiplied by the feature value.
To arrive at the correct answer, we focus on the keywords, ensemble of trees and neural networks, Vertex Explainable AI.
The correct answer is option B, configure sampled Shapley explanations on Vertex Explainable AI.
Why is this correct? B. Sampled Shapley is the recommended feature attribution method in Vertex Explainable AI for non-differentiable models, such as ensembles of trees and neural networks. Why are the others incorrect? A. The scenario explicitly requires using Vertex Explainable AI, making custom training of local surrogate models unnecessary and incorrect. C. Integrated gradients are meant for differentiable models like standalone neural networks and do not properly support non-differentiable components like decision trees. D. This approach describes a simplistic attribution method for linear models and does not utilize Vertex Explainable AI or capture complex nonlinear feature interactions.
You have a large corpus of written support cases that can be classified into 3 separate categories: technical support, billing support, or other issues. You need to quickly build, test, and deploy a service that will automatically classify future written requests into one of the categories. How should you configure the pipeline? The options are: Option A, use the Cloud Natural Language API to obtain metadata to classify the incoming cases. Option B, use AutoML Natural Language to build and test a classifier. Deploy the model as a REST API. Option C, use BigQuery ML to build and test a logistic regression model to classify incoming requests. Use BigQuery ML to perform inference. Option D, create a TensorFlow model using Google's BERT pre-trained model. Build and test a classifier, and deploy the model using Vertex AI.
To arrive at the correct answer, we focus on the keywords, large corpus of written support cases, classified into 3 separate categories: quickly build, test, and deploy, automatically classify future written requests.
The correct answer is option B, use AutoML Natural Language to build and test a classifier. Deploy the model as a REST API.
Why is this correct? B. AutoML Natural Language is designed to quickly build, test, and deploy custom machine learning models for text classification without requiring deep ML expertise, fulfilling all requirements. Why are the others incorrect? A. The Cloud Natural Language API provides pre-trained models for general sentiment analysis and entity extraction, but it cannot classify text into custom, user-defined categories like technical or billing support. C. BigQuery ML is optimized for structured tabular data and is not the most effective or appropriate tool for training custom natural language processing models on unstructured text. D. Building and training a custom TensorFlow model with BERT requires significant development time and deep machine learning expertise, directly violating the requirement to quickly build and deploy the service.
Your data science team is training a PyTorch model for image classification based on a pre-trained RESTnet model. You need to perform hyperparameter tuning to optimize for several parameters. What should you do? The options are: Option A, convert the model to a Keras model and run a Keras tuner job. Option B, run a hyperparameter tuning job on AI platform using custom containers. Option C, create a Kubeflow pipelines instance and run a hyperparameter tuning job on KDib. Option D, convert the model to a TensorFlow model and run a hyperparameter tuning job on AI platform.
To arrive at the correct answer, we focus on the keywords, PyTorch model, hyperparameter tuning.
The correct answer is option B, run a hyperparameter tuning job on AI platform using custom containers.
Why is this correct? B. AI platform training fully supports hyperparameter tuning for any machine learning framework, including PyTorch, by leveraging custom containers. Why are the others incorrect? A. Converting a PyTorch model to Keras is an unnecessary and complex step when native support via custom containers is available. C. Deploying and managing a Kubeflow pipelines instance for KDib introduces unnecessary operational overhead compared to a fully managed AI platform service. D. Converting a PyTorch model to TensorFlow is unnecessary since AI platform can run PyTorch directly using custom containers.
While monitoring your model training's GPU utilization, you discover that you have a native synchronous implementation. The training data is split into multiple files. You want to reduce the execution time of your input pipeline. What should you do? The options are: Option A, increase the CPU load. Option B, add caching to the pipeline. Option C, increase the network bandwidth. Option D, add parallel interleave to the pipeline.
To arrive at the correct answer, we focus on the keywords, native synchronous implementation, training data is split into multiple files, reduce the execution time of your input pipeline.
Correct answer is option D, add parallel interleave to the pipeline.
Why is this correct? D. Parallel interleave allows the input pipeline to concurrently read from multiple files, reducing I/O wait times and significantly decreasing the overall execution time. Why are the others incorrect? A. Increasing the CPU load without parallelizing the file reading operations will not resolve the I/O bottleneck inherent in a synchronous implementation. B. While caching helps reuse data across epochs, it does not address the primary bottleneck of synchronously reading data split across multiple files initially. C. Increasing network bandwidth is only relevant if data is being fetched over a network and does not solve the underlying synchronous reading bottleneck.
You recently designed and built a custom neural network that uses critical dependencies specific to your organization's framework. You need to train the model using a managed training service on Google Cloud. However, the ML framework and related dependencies are not supported by AI platform training. Also, both your model and your data are too large to fit in memory on a single machine. Your ML framework of choice uses the scheduler, workers, and servers distribution structure. What should you do? The options are: Option A, use a built-in model available on AI platform training. Option B, build your custom container to run jobs on AI platform training. Option C, build your custom containers to run distributed training jobs on AI platform training. Option D, reconfigure your code to a ML framework with dependencies that are supported by AI platform training.
To arrive at the correct answer, we focus on the keywords, critical dependencies specific to your organization's framework, ML framework, and related dependencies are not supported by AI platform training. Both your model and your data are too large to fit in memory on a single machine, distribution structure.
The correct answer is option C, Build your custom containers to run distributed training jobs on AI platform training.
Why is this correct? C. Custom containers allow using unsupported frameworks and dependencies on AI platform training. Because the model and data are too large for a single machine, building custom containers for distributed training is necessary to handle the large-scale workload. Why are the others incorrect? A. The scenario specifies a custom neural network with critical organization-specific dependencies, making a generic built-in model unsuitable for this task. B. While a custom container addresses the unsupported framework, a single container job does not solve the explicit issue that the model and data are too large for a single machine. D. Reconfiguring the codebase would require significant effort and might be impossible if the dependencies are critical. Custom containers provide a direct solution without rewriting the framework.
You work for a large retailer and have been asked to segment your customers by their purchasing habits. The purchase history of all customers has been uploaded to BigQuery. You suspect that there may be several distinct customer segments, however you are unsure of how many, and you don't yet understand the commonalities in their behavior. You want to find the most efficient solution. What should you do? The options are: Option A, create a k-means clustering model using BigQuery ML. Allow BigQuery to automatically optimize the number of clusters. Option B, create a new dataset in Dataprep that references your BigQuery table. Use Dataprep to identify similarities within each column. Option C, use the data labeling service to label each customer record in BigQuery. Train a model on your labeled data using AutoML tables. Review the evaluation metrics to understand whether there is an underlying pattern in the data. Option D, get a list of the customer segments from your company's marketing team. Use the data labeling service to label each customer record in BigQuery according to the list. Analyze the distribution of labels in your dataset using Data Studio.
To arrive at the correct answer, we focus on the keywords, segment your customers, uploaded to BigQuery, unsure of how many, most efficient solution.
The correct answer is option A. Create a k-means clustering model using BigQuery ML. Allow BigQuery to automatically optimize the number of clusters.
Why is this correct? A. BigQuery ML efficiently trains k-means clustering models directly where the data resides. It can also automatically determine the optimal number of clusters, addressing the uncertainty about the exact number of segments. Why are the others incorrect? B. Dataprep is a data preparation and exploration tool, not designed for building unsupervised machine learning models like k-means clustering for customer segmentation. C. Data labeling service and AutoML tables are used for supervised learning. This scenario requires an unsupervised learning approach because the distinct customer segments are unknown. D. The scenario specifies that you are unsure of the segments. Relying on a predefined list from marketing contradicts the need for data-driven discovery and requires manual labeling.
You recently joined a machine learning team that will soon release a new project. As a lead on the project, you are asked to determine the production readiness of the ML components. The team has already tested features and data, model development, and infrastructure. Which additional readiness check should you recommend to the team? The options are: Option A, ensure that training is reproducible. Option B, ensure that all hyperparameters are tuned. Option C, ensure that model performance is monitored. Option D, ensure that feature expectations are captured in the schema.
To arrive at the correct answer, we focus on the keywords, production readiness, tested features and data, model development, and infrastructure, additional readiness check.
The correct answer is option C. Ensure that model performance is monitored.
Why is this correct? C. Monitoring model performance is a critical production readiness check to identify and alert on model degradation after deployment. This is essential for maintaining ML systems post-release. Why are the others incorrect? A. Ensuring training reproducibility falls under model development, a phase the team has already tested. B. Tuning hyperparameters is part of model development, which is already completed according to the scenario. D. Capturing feature expectations in a schema is a component of testing features and data, which has already been performed.
Your team has been tasked with creating an ML solution in Google Cloud to classify support requests for one of your platforms. You analyzed the requirements and decided to use TensorFlow to build the classifier so that you have full control of the model's code, serving, and deployment. You will use Kubeflow pipelines for the ML platform. To save time, you want to build on existing resources and use managed services instead of building a completely new model. How should you build the classifier? The options are: Option A, use the Natural Language API to classify support requests. Option B, use AutoML Natural Language to build the support requests classifier. Option C, use an established text classification model on AI platform to perform transfer learning. Option D, use an established text classification model on AI platform as is to classify support requests.
To arrive at the correct answer, we focus on the keywords: full control of the model's code, serving, and deployment, build on existing resources, instead of building a completely new model.
The correct answer is option C, use an established text classification model on AI platform to perform transfer learning.
Why is this correct? C. Using an established model on AI platform for transfer learning provides full control over the code and deployment while saving time by building on existing resources, satisfying all constraints. Why are the others incorrect? A. The Natural Language API is a pre-trained service that does not provide full control over the model's code, serving, and deployment. B. AutoML Natural Language abstracts the underlying model, preventing you from having full control over the model's code and architecture. D. Using a model as is without fine-tuning it on your specific support request data will not accurately classify your domain-specific requests.
You work with a data engineering team that has developed a pipeline to clean your dataset and save it in a cloud storage bucket. You have created an ML model and want to use the data to refresh your model as soon as new data is available. As part of your CI/CD workflow, you want to automatically run a Kubeflow pipelines training job on Google Kubernetes Engine, GKE. How should you architect this workflow? The options are: Option A, configure your pipeline with Dataflow, which saves the files in cloud storage. After the file is saved, start the training job on a GKE cluster. Option B, use App Engine to create a lightweight Python client that continuously pulls cloud storage for new files. As soon as a file arrives, initiate the training job. Option C, configure a cloud storage trigger to send a message to a pub/subtopic when a new file is available in a storage bucket. Use a pub/subtriggered cloud function to start the training job on a GKE cluster. Option D, use Cloud Scheduler to schedule jobs at a regular interval. For the first step of the job, check the timestamp of objects in your cloud storage bucket. If there are no new files since the last run, abort the job.
To arrive at the correct answer, we focus on the keywords: save it in a cloud storage bucket, refresh your model as soon as new data is available, automatically run a Kubeflow pipelines training job.
The correct answer is option C, configure a cloud storage trigger to send a message to a pub/subtopic when a new file is available in a storage bucket. Use a pub/subtriggered cloud function to start the training job on a GKE cluster.
Why is this correct? C. Cloud storage can publish object creation events to a pub/subtopic. A cloud function can be triggered by these messages to automatically start the Kubeflow training job on GKE, providing an efficient, event-driven architecture that meets the real-time requirement. Why are the others incorrect? A. Dataflow is designed for data processing, not orchestrating event-driven job triggers. This option lacks a mechanism to automatically start the GKE job upon file creation. B. Continuously polling cloud storage with an App Engine client is an inefficient and expensive anti-pattern. Event-driven architectures using pub/sub are recommended for this use case. D. Cloud Scheduler relies on periodic batch execution. This approach does not satisfy the requirement to refresh the model immediately as soon as new data is available.
You are developing models to classify customer support emails. You created models with TensorFlow estimators using small datasets on your on-premises system, but you now need to train the models using large datasets to ensure high performance. You will port your models to Google Cloud and want to minimize code refactoring and infrastructure overhead for easier migration from on-prem to cloud. What should you do? The options are: Option A, use AI platform for distributed training. Option B, create a cluster on Dataproc for training. Option C, create a managed instance group with autoscaling. Option D, use Kubeflow pipelines to train on a Google Kubernetes engine cluster.
To arrive at the correct answer, we focus on the keywords: TensorFlow estimators, large datasets, minimize code refactoring and infrastructure overhead.
The correct answer is option A, use AI platform for distributed training.
Why is this correct? A. AI platform is a fully managed service that natively supports distributed training for TensorFlow estimators. It provides the most straightforward migration path with minimal code changes and the lowest infrastructure overhead. Why are the others incorrect? B. Dataproc is optimized for Hadoop and Spark workloads, requiring more manual configuration and infrastructure management for TensorFlow distributed training than a fully managed ML service. C. Using a managed instance group involves significant infrastructure overhead, as you would need to manually configure the VMs, install dependencies, and manage the distributed training environment. D. While powerful, Kubeflow pipelines on GKE requires managing a Kubernetes cluster and adapting your code into pipeline components, which introduces substantial infrastructure and refactoring overhead.
You need to design a customized deep neural network in Keras that will predict customer purchases based on their purchase history. You want to explore model performance using multiple model architectures, store training data, and be able to compare the evaluation metrics in the same dashboard. What should you do? The options are: Option A, create multiple models using AutoML tables. Option B, automate multiple training runs using Cloud Composer. Option C, run multiple training jobs on AI platform with similar job names. Option D, create an experiment in Kubeflow pipelines to organize multiple runs.
To arrive at the correct answer, we focus on the keywords: customize deep neural network in Keras, explore model performance using multiple model architectures, compare the evaluation metrics in the same dashboard.
The correct answer is option D, create an experiment in Kubeflow pipelines to organize multiple runs.
Why is this correct? D. Kubeflow pipelines allows you to organize multiple runs into experiments, store training data, and provides a centralized dashboard to easily compare evaluation metrics across different custom Keras model architectures. Why are the others incorrect? A. AutoML tables automates model creation for tabular data but does not allow you to design a customized deep neural network in Keras. B. Cloud Composer orchestrates workflows but lacks a dedicated, built-in dashboard for easily comparing machine learning evaluation metrics across different model runs. C. Running multiple jobs with similar names on AI platform does not automatically organize them or provide a unified, out-of-the-box dashboard for comparing their evaluation metrics side by side.
You need to train a computer vision model that predicts the type of government ID present in a given image using a GPU-powered virtual machine on Compute Engine. You use the following parameters: optimizer, SGD image shape equals 224, batch size equals 64, epochs equals 10, verbose equals 2. During training you encounter the following error: resource exhausted error, out of memory, OOM, when allocating tensor. What should you do? The options are: Option A, change the optimizer. Option B, reduce the batch size. Option C, change the learning rate. Option D, reduce the image shape.
To arrive at the correct answer, we focus on the keywords, batch size equals 64, resource exhausted error, out of memory, OM, when allocating tensor.
The correct answer is option B, reduce the batch size.
Why is this correct? B. Reducing the batch size decreases the number of samples processed simultaneously per iteration, directly lowering the GPU memory required and resulting the out-of-memory, OM, error without altering the input data quality. Why are the others incorrect? A. The choice of optimizer affects model convergence and parameter updates, but changing it does not significantly reduce the memory footprint required during the training process. C. The learning rate controls the magnitude of weight updates during backpropagation. Adjusting it affects training stability and convergence speed but has zero impact on memory usage. D. While reducing the image shape reduces memory consumption, it permanently degrades the input resolution and potentially reduces model accuracy, making batch size reduction a safer and preferred first step.
You are training a ResNet model on AI platform using TPUs to visually categorize types of defects in automobile engines. You capture the training profile using the Cloud TPU Profiler plugin and observe that it is highly input-bound. You want to reduce the bottleneck and speed up your model training process. Which modifications should you make to the tf.data dataset? Choose 2. The options are, Option A, use the interleave option for reading data. Option B, reduce the value of the repeat parameter. Option C, increase the buffer size for the shuttle option. Option D, set the prefetch option equal to the training batch size. Option E, decrease the batch size argument in your transformation.
To arrive at the correct answer, we focus on the keywords, TPUs, highly input-bound, reduce the bottleneck, tf.data dataset.
The correct answers are option A, use the interleave option for reading data. And option D, set the prefetch option equal to the training batch size.
Why is this correct? A. The interleave transformation allows reading and processing data from multiple input files concurrently, increasing throughput and resolving input bottlenecks. D. Prefetching allows the data pipeline to prepare the next batch of data while the model is training on the current batch, effectively overlapping I/O and computation. Why are the others incorrect? B. Reducing the repeat parameter changes the number of epochs the model trains for, but it does not improve the speed or efficiency of the data loading pipeline. C. Increasing the shuffle buffer size improves the randomness of the data but increases memory usage without speeding up data loading or alleviating the input bottleneck. E. Decreasing the batch size typically underutilizes TPU hardware resources and increases step overhead, which would slow down overall training rather than resolve an input bottleneck.